So we're going to go ahead and finish what we talked about in yesterday's video. So in yesterday's videos, you were doing things like looking for lengths of ribbons and trying to figure things out. And we didn't do very much, but we had fun and we figured a few things out. So today what we're going to do is kind of continue that and make it more formal. Gabrielle notices that the calculation she's making for the length of ribbons in the drill team reminds her of math class. So she says to the group, hey, I wonder if there's a way we can do this without having so we can do this with any 2 points on the grid. So she thinks about it like this. So you'll notice there's no x and y axis on this grid. So they're missing. So she's going to start with 2 points and draw a line between them, or the distance she's looking for. Since they can be anywhere, I name them x1, A, which is x1, y1, and B, which is x2, y2. When I figured out the length of the ribbons, what did I do next? So think about what we did. So the first thing we did was kind of draw in a rectangle. Now, we might be tempted to say this is 6 and this is 4, but it is not, because we do not know where x1, y1 is. We don't not know where x2, y2 is, so we can't say that even though there's 4 squares and 6 squares that it's 6, because this are supposed to be any 2 points in the world. They could be right next to each other, they could be ridiculously far apart. We don't know. So what we maybe what we figured out specifically from the ready is that we could subtract the one on the left from the one on the right, the one on the right minus the one on the left to figure out, hey, 4 minus -2 is 6, and that's how long CG is. So we kind of did that with the warm-up yesterday, with the ready yesterday. So here's our question is, how do we do this? And can we write down some ways to do this? So the first thing I need to do is figure out, I'm going to name this point, I don't know, maybe C, and figure out how long that is in math nonsense or gibberish. Not nonsense, we want it to be reasonable, but in math. So how long is that? Well, it's the horizontal move from x1 to x2. So what we're going to do is we're going to take the point on the right, which is x2, minus the point on the left, which is x1. And that will give us that length. And if I want to know the vertical length, so this length is the horizontal movement, the point on the left, x2, minus the point on the right, x1, is that length. So to find the vertical distance, it's not going to be quite so, but if we think about flipping our number line this way, if we were subtracting, we take the high point minus the low point. So the high point is y2 minus the low point y1. And that's how I'd figure out those sides. So just kind of ruminate on that for a minute. So what's happening is we're trying to figure out the distance between those 2 points. And so there they are. That's our distance. What did we do next? Well, next I added them together. I squared them, right? That's what's next. I squared them and added them. And then what did I do? Well, so first I figured out the length. So this was x2 minus x1, that's that length. This is y2 minus y1, that's that length. I've squared them, that's the result of doing that subtraction. What was next? What am I doing? Oh yeah, I'm doing the Pythagorean theorem. And the Pythagorean theorem says c squared equals x, excuse me, that's weird. A squared plus b squared equals c squared. So that's it. And then to get c alone, which is kind of what I have here, but we could kind of think of this as a squared, and that's b squared, and it's equal to c squared. But I don't want c. I don't want c squared. I just want c. So what I'm going to do is take the square root of that. This equals d. Now what I want you to do is write down some of the words I said to remind you what this means. This is the distance formula. So use this formula that we came up with to see if we can find any 2 points. This is really useful when the points aren't nice, when we have decimals, when the distance is gigantic and I don't want to count 35 or something like that. So let's go ahead and use this formula, which is called the distance formula that we just created. And I'm going to write it down right up here at the top of the page because I don't have it anymore. D equals the square root of a very big mess. x2 minus x1 squared plus y2 minus y1 squared. And so the distance formula. So now I'm going to go, okay, here's my 2. So it's more efficient than graphing and counting. And notice these are really far apart. I would not want to graph and count this. So I'm going to go ahead and set, excuse me, I don't know what I'm doing there. I'm going to go ahead and set it up here. So I'm going to have the x's. So I'm going to take the one, so 23 minus negative 11 and square that, plus negative 16 minus, excuse me, that's supposed to be a comma, minus 25, and I'm going to square that. So here I'm going to get 34 and square that. And over here I'm going to get negative, negative 41. And notice it's in parentheses. This is important, and square that. I'm running out of room because finger writing takes a lot of space. And so I get 34 squared is 1,156 plus M41 squared. And I'm going to make sure I do this right. So I'm going to start with parentheses, negative 41 on my calculator. And then I'm going to square it. And I get 1681. So you might wonder, well, why isn't it negative? Because a negative times a negative is a positive. I add those two numbers together. And I get 2,837. And now I take the square root. So the whole time that square root's kind of been hanging out and I've been ignoring it because it's annoying. So I'm going to stick it back on because I wanted us to kind of think about what we had to do. So the first thing we do is figure out this number, which was 34. The next thing we do is figure out that number, which was negative 41. The next thing we do is square this number. Get this, square that number, get that, add them together, then take the square root with my calculator of 2,837 and get approximately 53.26 units because it doesn't tell us what. And we're finished. So that's pretty cool, and it works, and it does what I need it to do. I totally covered up number 6, so we're going to fix that in just a second. But that's the idea of using the distance formula. So we're going to use the process to find the perimeter of the hexagon. And so let's go back and find the hexagon that we're going to try to find the perimeter of. This thing, I'm going to just take a picture of it. I'm going to clean it up and take a picture and put it on my other page. And here we go. So now we're going to try to find the perimeter of that. Now, if you remember, in number 3, we figured out the length of BC, and I'm a fool who didn't bring that number with me. So I'm going to go back and find it. And of course, I erased it. So I'll just start over. So we're going to do, this was the square root of something. What was 4 and 2, so it was 16 plus 4, which is 20. It's square root of 20. So what's cool is this is also the square root of 20, and this is the square root of 20, and this is the square root of 20. Anybody want to tell me why? I know, I can't hear you. I keep asking you questions you can't possibly answer. But the square root of 20, because those are all the same length, because they're all 4 away this way and 2 this way. And so on, all the way around it. This, however, from here to here, this is 6, and that is 6. So I'm going to add all those up, and this is where it gets tricky. So I'm going to grab a calculator. I'm going to do 6 plus 6 plus the square root of 20 4 times, or 4 radical 20. That looks weird. I'm not going to make that. It's confusing. Although next year we're going to write it. Okay. I'm going to use my calculator now. Okay, and we have 29.8888. So 29.9 units. And that's my perimeter of the hexagon. So that's pretty cool. Your homework today, sorry, well, I'm giving you a chance to actually process that. So I just found the length of each side, and I actually totally cheated because I used this number that I already found. Why start over? And, but that's okay. Our homework tonight will be the set. So you're going to be doing 11, 12 through 15. And so in here, they're asking you to kind of think about the slope formula, which is y2 divided by x2, y2 minus y1 divided by x2 minus x1. And so remember, I already answered these two questions in the video. So if you want to back it up to when I was talking about what we were doing with the distance formula, that'll solve your problems. And then the same thing here is we're going to either use the formula we just created, or you can use the Styrene Theorem. I'm totally cool with whatever you do, but I promise you 15 and 14 are easier with the formula. I'm not going to do either of those for you, but that's your homework today. I'll talk to you, again tomorrow.